welcome to the channel of Digital to Real. Today I am going to solve one question asked in GATE Computer Science 2003. Consider the ALU shown below. Here is the circuit. Full adder, cascaded. C0 is the input to the first full adder. A0 is another input and the third input is actually B0 XOR K. Output is S0 and carry coming out C1. C1 is input to another full adder. One input is A1. Other input to the full adder is B1 XOR K. Output of the full adder is S1 and carry. So, if the operands are in 2's complement representation, which are the following operation can be performed by suitably setting the control lines K and C0. Here is the K control line going to this particular XOR and going to this particular XOR, and C0 is the carry input to the 0th bit of the full adder. Then now plus sign and minus sign, they denote the addition and subtraction respectively. Now we have to choose the option out of 4. A plus B and A minus B but not A plus 1. B, A plus B and A plus 1 but not A minus B. C, A plus B but not A minus B or A plus 1. D, A plus B and A minus B and A plus 1. Solution of the question. Operands are in 2's complement representation. Signed binary number means positive numbers are simply represented as binary representation. But if the number is negative, the number is represented using 2's complement. That is 1's complement plus 1, and 1 bit position is occupied for sign bit. So plus 5 is represented as 1 sign bit, other 4 bits are for the magnitude 0, 1, 0, 1, MSB, LSB. Okay, and this one is the sign bit. This is how the for signed binary number, positive number are represented. Now minus 5 is represented as 2's complement is the magnitude is the 2's complement of 5. Okay, 1, 0, 1, 1 is the 2's complement and of 5. And 1 bit most significant, after the most significant bit, 1 bit is for the sign bit. Okay, this is how the minus 5 is represented in the 2's complement representation. Now in our circuit, K and C0 are the control bits. So the possible combinations which K and C0 can take is 0, 0, 0, 1, 1, 0, 1, 1. Another point to be noted that for XOR gate, if X is the input and another input of XOR gate is 0, then output of the XOR gate is equal to X. And for 2-bit or 2 input XOR gate, if one input is X and other input is 1, then the output of the XOR gate, you see out is equal to X exclusive or 1, that is coming as out is coming at X bar. That is X complement. Now the 2's complement of a number is 1's complement plus 1. 1's complement means complement of each of the bits plus 1. Now when K is equal to 0 and C0 is equal to 0, so for that combination you see here K is 0 and C0 is 0. So for this full adder C0, A0, B0 and XOR K is another input. B0 XOR 0 is B0 only. And here C1 is going to the full adder. One input is A1, other input is B1 XOR K. K is 0. So output of the XOR is B1 only. So the circuit would look like this. B1 A1, B0 A0. This is a full adder. This is a full adder. This is C1, C0, and this is the output of the carry output of the final full adder S1, S0 bit. This is the look of the ripple carry 2-bit circuit, ripple carry adder. Okay, so it's a 2-bit parallel adder. So A plus B is possible. We can, for 2-bit addition, 2-bit number, this addition A plus B is possible with this circuit. Now for K is equal to 0 and C0 is equal to 1. K is equal to 0 again and C0 is equal to 1. Output of the XOR, this 2 XOR, output of this XOR is B1, output of this XOR is B0. But C0 is here now 1. The circuit would look like this. Okay. So, what is the possible addition? A plus B plus 1. This particular addition is possible with this circuit. Now, for K is equal to 1, C0 is equal to 0. Now, K is equal to 1, C0 is equal to 0. For K is equal to 1, output of this XOR gate is B1 bar and output of this XOR gate is B0 bar. The circuit would look like this. Full adder cascaded together. This particular full adder has the carry input 0, 0, 0. Other input is A0 and the third input is B0 bar. That is B0 complement. S0 C1 going to this full adder. A1 is one input and other input is B1 bar. That is B1 complement. Output is S1 and C2. Now, here the addition is happening for A plus 1's complement of B. Because B0 and B1 are both complemented. So, A plus 1's complement of B, this addition is happening with this full adder. So, this is not a valid option we have. In the question, we were having A plus B, one option, A minus B, but not A plus 1. There was A plus B and A plus 1 but not A minus B. A plus B but not A minus B or A plus 1. A plus B and A minus B and A plus 1. So, there was no term as A plus 1's complement of B. Actually, this 1's complement of B plus 1 becomes minus B. So, 1's complement of B is equal to minus 1 minus B or is equal to minus bracket B plus 1. So, output of this full adder would be A minus B minus 1. So, this particular term is itself is not there in the question. This particular term is possible for combination K is equal to 1 and C is equal to 0 for the control lines. Now, for the combination K is equal to 1, this is the fourth combination with K is equal to 1, C0 is equal to 1. So, this circuit would look like this. Now, K is equal to 1, so output of this XOR gate is B1 bar and output of this XOR gate is B0 bar. Okay, and C0 is now 1. So, C0 is 1, one input is A0, other input is B0 bar. For this full adder, one input is A1, other input is B1 bar. Okay, so this one is equal to A plus the addition. The result which I will get is actually, for some bits, the result which I will get is A plus 1's complement of B, because both the bits B1 and B0 are complemented, plus 1. So, A plus 1's complement of B plus 1. 1's complement of B is actually minus B. So, A minus B. So, this particular term is also possible. Now, we will look at the question, the options given. A plus B and A minus B but not A plus 1. So, A plus 1, this addition we have not done for any combination of K and C0. We only did A plus B and A minus B. So, these two are valid but not A plus 1. Now, second option is with the combination of K and C0, A plus B is possible and A plus 1 is possible but not A minus B. A plus B is possible for the circuit plus A plus 1 is not possible, while A minus B is possible. So, this particular statement is wrong. Now, we will see the third option. A plus B is possible but not A minus B or A plus 1. A plus B is obviously possible but A minus B is also possible but not A minus B or A plus 1. A plus 1 we have not arrived, but with this circuit For a certain combination of K and C, A minus B was possible. So this statement is also wrong. Third option we will see. A plus B and A minus B and A plus 1. So this statement is saying that this particular combination is possible, A plus B with the circuit. A minus B is also possible with the circuit and A plus B is also possible with the circuit. This statement is wrong because obviously A plus B and A minus B is possible but not the A plus 1. So the answer is the option A plus B and A minus B but not A plus 1. If you like the video, share with your friends. Please subscribe the channel and have a very nice day. Bye-bye.